This is section 2.2, which talks about biconditionals and definitions. So let's first talk about what a biconditional statement is. So this has some parts to it that you have to be aware of. The first thing that you have to be able to know before even writing a biconditional is that certain things are true. So two things have to be true in order to write a biconditional. And the first thing is that the converse, which is where the hypothesis and the conclusion are switched, and the conditional statements must be true. So a biconditional takes both of these and combines it into one statement. So a biconditional statement is a statement that you get by connecting the conditional and its converse with the phrase if and only if, which we happen to know a little shorthand for if and only if, and it's this right below, IFF. So you don't have to write out the entire part of if and only if. You can simply write IFF and I know exactly what you're talking about. So the next thing that we're going to do is look at an example to see exactly how this biconditional statement is written. Alright, so let's take a look at this conditional statement. It says if two angles have the same measure, then the angles are congruent. So before we can do anything, we want to make sure that this is a true statement, because in order to write a biconditional, the conditional and the converse must both be true. So is this a true statement? If two angles have the same measure, then the angles are congruent? You bet. That is a true statement. Okay. Now let's write the converse, where we switch the hypothesis and the conclusion. Okay, so here's the converse. If the angles are congruent, then two angles have the same measure. So is that a true statement? And the answer here is yes, that is a true statement. So since both of these are true, I can write a biconditional. And I want to make sure that I use the phrase if and only if in between. So I don't need an if and I don't need a then. Everything is taken care of with that if and only if. So I'm going to get it set up first and I'm going to show you how to construct this. Okay, so I have my if and only if part smack dab in the middle. I'm going to have a phrase on the left and a phrase on the right that has to come from my conditional statement. So look up at the conditional and let's look at the hypothesis. The hypothesis said, without the if part, that two angles have the same measure. So that is going to go before the if and only if part. So let's get that written. Okay, and I had to move the if and only if I ran out of space. Two angles have the same measure, if and only if. Now the last part that we need to do here is attach the conclusion of the original conditional statement. So I'm going to look back up here. Without the then part, it would be the angles are congruent. So that goes after the if and only if part. Alright, there we go. Now let's make sure that when we read it, it sounds right. So it's going to say two angles have the same measure if and only if the angles are congruent. And that definitely sounds true. So let's try to do another one together. And we'll go from there. Alrighty, so here we go. Our conditional statement this time is if 3 points are collinear, then they lie on the same line. Let's first determine if that's true or false. Alright, if you said true, you would be correct. That is a true statement. Alright, now I want us to write the converse. And if you think you know what it is, I want you to write it out first and then check it with my answer. Alright, so you should have had something along these lines. If 3 points lie on the same line, then they are collinear. And I know that this 3 points part came from the hypothesis, but it would be really, really difficult to write this first part without it. It would be very arbitrary and we'd be pretty specific. So it's okay if you bring down a piece of information like that. Now let's determine if this is true or false. Go ahead and think about it. And if you said true, you would also be correct. So now that we have this information, let's go ahead and try to make the biconditional statement. Alright, so If you'd like to try to do this on your own, go ahead and pause the video right now, and then when you're ready, go ahead and press play. If you're still unsure, let's go ahead and find the hypothesis of the original conditional statement. And that would be right here. 3 points are collinear. So that's going to be the first part of my biconditional statement. Alright, so there we go. 3 points are collinear. Now we need the if and only if part. And then the last part that we're going to write is the conclusion of the conditional statement. They lie on the same line. And there we go. So let's first of all read this back to ourselves and make sure that we got this right. 3 points are collinear, if and only if they lie on the same line. That sounds pretty good to me. Next thing we're going to look at our definitions and why they're important in math. Oh, and by the way, there's a symbolic form for this as well that I forgot to mention. If you remember, conditional statements are P, then Q. A converse statement is Q, then P. So what is a biconditional statement? Well, it's P and Q, but it's true in both directions. So that is our symbolic form of biconditional statement. Alright, so we need to talk about good definitions. So, first of all, in this class, we started with some vague definitions with point, line, and plane, and we came to define it a little bit more clearly, and we understand what they mean more, a little bit better. So we then use those definitions to build upon other definitions, such as collinear points, coplanar points, and other things like that. In order to build your knowledge in mathematics, you have to understand the definitions and what they mean. And you're going to see this a little bit later on in proofs. Remember that math is logical reasoning. Same thing with what lawyers do. They have to argue a point, and they can't argue a point unless they know exactly what they're talking about. And that's what we have to do in math. So there are 3 things that we have to look for when we write a good definition. Here's the first one. Alright, the first thing is that a good definition needs to use clearly understood terms. This means that you don't write the word stuff or things. You're giving me specific information that you understand and that other people can understand as well. The next thing is that your good definition has to be precise. You don't want to use arbitrary words like large or sort of or almost. You want to give specific measurements, if you can, or any kind of word that can't be changed just because of somebody's perspective. Large to you may not mean the same thing as large to me. So let's look at the last one, and this is that it has to be reversible. That means that you can write your statement as a true biconditional statement. So we're going to take a look at an example. We're going to be given a definition and then have to write that as a conditional, as a converse, and a biconditional to see if it truly is a good definition. Alright, so here's our first definition. It says perpendicular lines are 2 lines that intersect to form right angles, or 90-degree angles. So we first want to write that as a conditional statement. So I have my if-then part all planned out. So this takes a little bit of time and a little bit of practice to get good at, but see if you can pause the video and determine what the if part would be and the then part, the hypothesis and the conclusion. Okay, so I would do if 2 lines are perpendicular. And I'm going to use shorthand for perpendicular because it's a long word and I'm a math teacher and I'm not a big fan of writing out big words if I can't help it. So I like to use symbols, and that's okay to do in math. So if 2 lines are perpendicular. So it actually took care of all of this information right here. So that's good. So then the then part would be that they intersect to form right angles. Alright, so hard part is done. Conditional statement is finished. If 2 lines are perpendicular, then they intersect to form right angles. So now in order to see if this is a good definition or not, we have to get this to be a biconditional statement. So if you want to try it on your own, pause the video here and write the converse and the biconditional, press play, and then check your answers with mine. If not, let's go ahead and do this together. Alright, so here is my converse. I switch the hypothesis and the conclusion. If two lines intersect to form right angles, then they are perpendicular. Remember that in order to write a biconditional statement, both of the conditional and the converse must be true, so let's determine that. So the conditional statement, two lines are perpendicular, then they intersect to form right angles, that is definitely a true statement. And then the converse, if two lines intersect to form right angles, then they are perpendicular. That is also a true statement. So we know that we can write the biconditional statement with the phrase if and only if. Alright, so here's the hypothesis of the first conditional statement. Two lines are perpendicular. Now I have to connect this to the conclusion with if and only if. And the next part is going to be that they intersect to form right angles. Alright, there we go. Now since I can write this statement as a biconditional statement, all of my terms are clearly defined, and all of my information is precise, that I know that the original definition is a good definition. And that concludes this tutorial.